Hey everybody, Mr. Gibson here. So I just wanted to record a video for getting you to get you started on this assignment, elaborate molecular geometry. So this is kind of just an extension assignment. This is not something that will necessarily be on a quiz or something like that, but it lets you dive a little bit deeper into the idea of molecules, or when more than one atom is bonded together. In 4.2, we're going to talk quite a bit about molecules, and the macromolecules are really big molecules. So it's important that you can kind of get this concept in your head of what a molecule is and what it looks like. So we're going to do that through this activity called molecular geometry. Now, don't be afraid of the word geometry. This is not like your geometry math class. This is a little bit different. So to get started, let's open up this simulation here. I think the simulation is pretty cool. It's pretty new from PhET. And when it loads, so you can use the model or you can use real molecules. You'll actually end up doing both today. And so when you click on this, it shows you the three-dimensional shape of a molecule and its bonds. Okay, we've got single, double, and triple bonds that we can add to it, and you can tell as we you can add electrons, and as we add components to this molecule, its shape changes or its geometry changes. And so we can click for it to show lone pairs. You'll need today to click to see what the angles of the like the geometry of the molecule is. So between these two single bonds here, it says it's 90 degrees. And it gives you the name of the molecular geometry and of the electron geometry. You might need that today too. Okay, so it's pretty simple. Some new words that you may not have seen, like trigonal bipyramidal and electron geometry. But as far as the concept of it, we're just dealing with what shape a molecule is, depending on how many bonds it has or how many lone pairs of electrons are kind of just sticking out there off of the molecule like that. Okay. And so you're going to use that to answer the questions and fill out the charts on this Google Doc. It gives you pretty clear instructions on what to do. Okay. First, you'll predict how does the shape of a molecule change as we add more bonds or add more electron pairs. Again, your prediction, whatever you put there is okay. I mean, you've got to put like some intelligible answer. It can't be nonsense. But it has to be pertaining to this assignment is what I mean. But if it's wrong, that's okay. We're wrong about our predictions in science all the time. The point of an experiment like this is to determine whether or not evidence supports our prediction, and if we maybe need to change our conclusions to fit the evidence. Okay, so you're going to fill this in for part one, and then so on and so forth. There was a part that had you draw the angles. I took that off because the drawing tool on Google Docs, I figured that would take too long. So you simply have to type in what the name of what the geometry is. Like here, this one, I just threw this together. This isn't even anything real, but it's seesaw is the shape. So you would type that there, and then you would type in the different bond angles. So for this one, it would be 90 degrees and 120 degrees. Okay, and you'll do that for all these different scenarios, all these different combinations for that molecule. Okay, and then for part two, you're going to use the real molecules, where you'll go in and let's see here. Let's open this up again, and you'll open up the real molecules tab this time. And so this one is water, for example, and it will have you fill in that same information, the molecular geometry and the angle of the bonds for each of these actual real life molecules. Okay, and then you'll have to answer these conclusion questions. All right, it's not too terribly complicated, but if you guys need any help or if any part of this is still confusing, feel free to email me. All right, good luck, guys.